we're going to take a look at, this is going to probably be the last lesson for financials. And we're just going to look at what are called annuities. Okay, so they're like what something's going to be worth in the future, right? If you contribute, let's say in the examples here, $250 a month, or annually you get $500 for a scholarship, or an insurance policy provides a pension of $2,000 per month, right? How much are we going to put in order to get this much out at the end, right? That's what future value is worth. Okay, so annuities, the same thing as a future value. Okay, and then so we can define annuities as being a series. I'm going black here. A series of equal payments made at equal, let's see if I fit this, intervals. Okay. Okay, and an ordinary annuity, okay, is just going to be something that payments are made at the end of a payment period. Okay, so payments okay. Now, again, we'll go through some examples here. Making car payments of $250 at the end of each month. Okay, scholarship fund provides an annual scholarship of $500. An insurance policy provides a pension of $2,000 per month. Okay, so now that we know what that is, let's go back up here to our learning goal and success criteria today. Okay, so your learning goal for today is going to be that you're able to calculate the future value of annuities. Okay, so something that's happened on a regular basis, how much is it going to be worth at the very end? And some of your success criteria is going to be, can you define what an annuity is, which is what we just went through? Okay, and then again, we're going to be able, can I define R, I, and N from a word problem? And then can you apply the formula for the future value of an annuity? Okay, so there's your equation right here. Okay, that's what the future value is. Okay, and it just, again, I and N are going to be the same I and N that we've been kind of dealing with. Okay, R in this instance changes. Okay, so it's not little r, it's capital R. Okay, and we'll define these here. Okay, so A, or not A, sorry, FV, or future value, is going to be what? It's going to be future value. Okay, so it's almost like the A value from some of the other equations, right? Now, R is going to be what your regular payment is. So almost like, it's like your principal, but like you're applying the principal many times, right? So this is going to be the regular payment. Okay. I is the interest rate. Per interest period. Okay. And N is going to be the total number of interest periods. Okay. So, without further ado, let's just take a look at an example. Okay. So Lisa plans to deposit $500 at the end of each month for 5 years. Okay. If the account pays an interest of 9% per annum per year, compounded monthly, what will be accumulated at the very end? Okay, so we're looking for that future value. Okay, so we know we're going to use this equation, right? So I'm going to go FV is going to equal R multiplied by 1 plus I to the power of N minus 1. Okay, this equation is a little bit more complicated than maybe what we've seen. Okay, But again, you can tackle all of these equations in the exact same way, where I identify what my knowns and unknowns are. I select the equation that I want to use first, maybe, and then identify your knowns and unknowns, and then you just plug things in and apply some of the rules that we've been working with exponents, right? That's it. You get a number, you interpret the number, right, based on the question. That's it. So on the left side here, I'm going to say, okay, the future value, I don't know. Okay. The R value is how much money she's putting in at the end of each month, right? So R in this question is going to be 500. Okay. And then you're interested in the other two variables, which in this question are I and N. Okay. The interest rate that she's earning is 9% every year. Okay, so it's 9% for the year. Okay. Remember, it can't be expressed as a percentage. It has to be expressed as a decimal, so you have to divide that by 100, 0.09. Now, there's one other thing here. It gets compounded monthly, which means you're earning a small percentage of that 9% every month, right? And so you're going to have to take the 9% and divide it by 12, right? In which this should equal, if we go 0.09 divided by 12, should get 0.0075, okay? Okay. And then N is the total number of compounding periods over all 5 years, right? So N, N is going to be the 12 times it gets compounded per year, because it's monthly, so it's a 12, and then it's in there for 5 years. Okay, so you multiply by 5, okay, which is going to be 60. You're going to get 60 compounding periods. So here are the numbers you're going to use. Put a little red box around them. Okay, these are going to go into your equation. Okay. So let's just write these things out, and we'll plug them in. Okay. So the future value is going to be equal to 500 multiplied by 1 plus 0.0075 to the power of 60 minus 1. Okay, you got to do all of that, and then you got to divide everything by the I value, which was 0.0075. Okay, so let's do what's inside the square brackets first, and then even before we do that, we got to do what's inside the round brackets, and then apply the round bracket answer to the power of 60. Okay, so what we're going to do here is we're going to go 1 plus 0.0075, okay, and that needs to be to the power of 60. So you're going to click your x to the n to the power of 60 is 1.566, we'll call it, okay. So you're going to get FV is equal to 500 multiplied by 1.566, okay. Then you have to subtract the 1, okay, because that's what's still in the square brackets, and then all of that divided by 0.0075, okay. So there's not much room here. I didn't anticipate how big this would be. Okay. So again, just to highlight here, you're just doing math on this, right? So this is what I've done here. So what I've highlighted in red, okay, is this number. That's the math I did, okay. And then I'm just going to finish this question out because I'm tight for space here, okay. And that'll be the end of part 1, and then we'll move on from here, okay. So let's take a look at, so let's just do the math on this. So 1.566 minus the 1 is just going to be the 0.566, right? Then what you're going to have to do then is multiply that by the 500, okay, is 283, okay, divided by the percent, or sorry, the interest rate that's sitting there, right? Okay, so you get 283 divided by 0.0075. This is what's going to equal the math that you do on this, the future value. This is how much it's going to be worth after whatever's happened here under these conditions, right? Divided by 0.0075. Okay. The future value of this and 33 cents. That's what the future value is going to have. So then you could say Lisa will have $37,733.33 after 5 years if she puts $500 into this account, okay, every month. Okay, so something like, if you're looking at a perfect application of this would be like, let's say you're, and I didn't do this too long ago, let's say you're like, you finish school and you're renting an apartment and your desire to buy a house comes into play, right? So you're like, okay, well, I need a minimum percentage to put down on a house in order to for the down payment, right? So you're like, okay, well, how much money do I have to put away every month in order to get that down payment, right? And the down payment's going to, obviously the down payment's a percentage of whatever you're going to pay for the house, right? So you're going to have to pick what you think you can spend on a house if it's $400,000, and then you're going to have to put away a percentage of that, right? Well, how much money do I have to put away every month into maybe a tax-free savings account, right? Or something like that. That's going to give you some amount of percentage. Maybe it compounds monthly, exactly like what Lisa has here, right? And then you can actually figure out how long am I going to be in this rental if I put this money away every month, okay, before I'm able to actually buy the house.